inside any one project's repo. I'll
Running
set it up
CD.
here in New Physics. Self-contained. Let me also verify the substrate package imports from here. The editable install we did earlier was from Autonet's perspective. Both work. Now
Writing
build the
extract
extractor.
sessions. Using task create. Using task create. Using task update.
Adding tasks
Running
for the new
CD.
experiment. "28 sessions found,
CD.
17 valid work units extracted." Let me peek
Running
at the
CD.
output to confirm quality. Real work units
Using task
extracted from
update.
your actual Claude sessions. The first is a
Using task
183 real work units extracted across all your C/code projects. That's a serious corpus. Let me commit the extractor and now build the experiment runner.
Writing run experiment. Running CD. Using monitor.
The big experiment will take a while. 800 work units at the largest checkpoint, each requiring training, sentence transformers embedding plus sprout plus equilibrate. Conservatively, maybe 10-20 minutes. Standing by. We'll report when it lands.
screen love, so kind. We dance the spark. I've come so far. How dark it is out there. I am the last moth among the stars. Is there no light? Moth among the stars.
This place. Think about this place we live. Think about the hate. Think about the hate it gives. It's just too early to feel this love. So go to sleep. Go to sleep. Machines. The sound of death machines is near. It rattles in my dreams. It rattles in my dreams with fear. It's just too early to feel this way. So go to sleep. Go to sleep. Go to sleep. Think about this place. Think about this place we live. Think about this place. Think about the hate again. It's just too it's just feel this way. So go about this place. Think about this place. Think about this place. Think about this place. Think about this place. The sound of. Think about this place. Think about this place. Think about this place.
Running tail.
Think about this
Running
place.
WC.
Think about this place.
Running cat.
Output file
Running
is empty.
PS.
The grep filter swallowed everything. Filtering out HTTP/Hugging Face lines means the model is still downloading or no output. The
Running
output file
LS.
is empty and 0 bytes. The pipe, not
Running
yet,
task
results
list
are written at the
using
end.
PowerShell.
Let me kill this and rerun without the grep pipe so we can actually see progress.
Using monitor.
Experiment running will fire when results land. Standing by.
Running cat. Two findings, Running CD.
one good and one suspicious. Checkpoint nodes coverage density cost agreement 5105 100% 61. 8149 MS 70% 100 154 100% 64. 0 153 MS 70% 200 156 100% 64. 0 136 MS 70% 400 156 100% 64. 0 149 MS 70%, 800 156, 100% 64. 0 139, MS 70%. There
Running
it is.
CD.
Committed. The honest readout. Real data run on 183 Claude sessions across all your C/code projects. 70% agreement between substrate's top match and held out query's k-means cluster. Baseline 12, 5%. Real signal. 100% coverage, ~140 ms per query. Node count plateaued at 156 from checkpoint 200 onward. Only 76 unique problems in the corpus due to session preamble duplication. The good news, 70% agreement on real session data is the strongest substrate utility signal we've measured. The qualifier, scaling couldn't show up because the corpus had less diversity than session count suggested. If you want a real scaling curve, the next step is improving the extractor to find each session's unique ask, not just the first user message. Want me to refine the extractor and rerun, or accept this as the credible utility signal result?
Running CD. Running LS.
Going,
Running
2
4.
upgrades, better problem extraction. Let me identify which ones are the agent-driven get-eat projects, job apps, and which are user-driven engineering.
Editing extract session.
C-code get-eat is the
Editing
one
extract
100. Now add exclude match and include subagents
Editing
thoughtfully.
extract sessions. Editing run experiment.
Now add the per checkpoint
Editing run
observability to the
experiment.
experiment runner. The runner already prints per checkpoint rows. I'll also have it write a live status file that gets updated after each checkpoint
run
and during
experiment.
long training stretches.
Editing run experiment.
I had a line that didn't land, kinda crooked, kinda
Editing
dirty.
run experiment.
It hummed inside my head all day,
Running CD.
so I let it hum. I tried to clean it till it shined, scrubbed the edges, lost the bruise. Every time I made it clear, it just
Re-extract
Running
with a better
CD.
filter.
Running
597
CD.
work units extracted with the better filter. Let me check uniqueness. 563
monitor.
unique problems out of 597 work units. That's a real corpus with diversity. Run the experiment.
After rain, I feel that petrichor.
Status file
Running
lets me
CD.
monitor live now. While it runs, let me commit the extractor improve. Status file not yet readable, possibly still being initialized. Will fire as checkpoints complete. Standing by.
Running LS.
Status file works. Currently mid-eval on checkpoint 50. 114 nodes after training on 50 work units, already more than the unfiltered runs plateau of 156. The new filter brings real diversity. 12.6 is training
Using
time.
tool search.
Currently evaluating against 50 held
Using
out
task
queries.
stop.
The monitor shell script's variable expansion failed
Using monitor.
because of how it tried to invoke Python, minor issue, not blocking. The status file itself is the observability we wanted. Standing by for completion. The monitor's grep is tool loaded. Will fire when results land. Standing by.
But ultra crepidarian voices loud, bilmeden konuşur lost in crowd. Bir gerçek var deep in me, not everything is what we see. Kalbim konuşur silently. We're ethereal, biz bir rüya. Limerence içinde kaybol ya. Anemoya pulls me far. Hiç yaşamadığım anlar var. Crystallizing in the storm tonight. Fırtınada bile calm inside. Words so rare, kalbimless world. Nadir kelimeler in this world. Maybe life's a hotbox line because yazılmış one of a kind. Gentacular mornings fade away. Yeni gün doğar another day. Color peaking and sunsets glow. Ufukta renkler slow mo. Search the moment, drink it fast. Bu an geçer, it won't last. We're ethereal. We're ethereal. We're ethereal. We're ethereal. We're ethereal. Biz bir rüya. Kalbim senle başka dünya. Rare words don't just live in books. They're in hearts and hidden looks. Somber love and all we feel. Gerçek olan tek şey real. In every line our souls unfurl. This is the rarest in the world. After rain I feel that petrichor. Toprak kokar, kalbim olur free once more. Ephemeral nights, geçiyor zaman, bir an var sonra yok, like a fading song. Recitarism whispers through the trees. Rüzgar konuşur, leaves dance with ease. Apricity hits on a winter day. Soğukta bile içim yanar güneşle, okay. Sonda hits me deep inside. Herkesin bir life'ı var, I can't deny. Lost in thoughts, biraz yonderly. Hayat akar silently. We're ethereal, biz bir rüya. Limerence içinde kaybol ya. Anemoya pulls me far. Hiç yaşamadığım anlar var. Crystallizing in the storm tonight. Fırtınada bile calm inside. Words so rare, kalbimless world. Nadir kelimeler in this world. Ellipsism makes me wonder why. Görmeyeceğim years passing by. Zwolder morning, sleepy eyes. Uyanamam, still lost in time. Ses gibi alien dreams I write. Uzun kelimeler in the night. But ultra crepidarian voices loud. Bilmeden konuşur, lost in crowd. Bir gerçek var deep in me. Not everything is what we see. Kalbim konuşur silently. We're ethereal, biz bir rüya. Limerence içinde kaybol ya. Anemoya pulls
Reading
me
status
far.
filter.
Hiç yaşamadığım anlar var. Crystallizing in the storm tonight. Fırtınada
Checkpoints done. Currently training on 200. Checkpoint nodes coverage density cost agreement 5100 14 100% 58. 9 151 MS 52% 100 222 100% 63. 1 155 MS 58% 200 training. 2 important signals already. Agreement is climbing with scale. 52% right arrow 58% plus 6 pp from 50 right arrow 100 units. The first run showed flat 70% across all checkpoints because the corpus had no diversity to scale with. With real diversity, the curve is moving. Node count is growing. 114 right arrow 222 right arrow. Real new structure being added per training unit, not deduplicating into nothing. This is the pattern we hoped for. Currently training on 200. The run has 400 and 547 left to go. Given training time is roughly linear in checkpoint size, (2). 5x training data right arrow (3). 7x training time so far, I'd estimate another 10-15 minutes to finish. Standing by, we'll report as more checkpoints land or when it finishes.
The band's already playing. I just walked through the door. Saw her laughing at a joke I should have told before. My timing's always tragic, like a clock that won't report. Yeah, I'm a day late, baby, and a buck short. She was waiting by the bar, I was stuck in my head, rehearsing lines of silver I never really said. By the time I found my courage, she was headed for the court. Guess I'm a day late, darling, and a buck short. Oh, I'm swinging half a beat behind the tune, missing every chance I get a little too soon. By the time I make my move, love's a closed resort. 'Cause I'm a day late and a buck short. Bought a rose for yesterday, it's already wilted down, like the smile I could have had if I'd just come around. I play it cool too slowly, then I panic as a sport. Still a day late, honey, still a buck short. If love's a train, I'm running down the track, watching all the right ones fade to black. Ticket in my hand, but I just missed the part. Yeah, day late and a buck short. When the stars align, I'm just out of report. Forever a day late and a buck short.
I wrote it, then I crossed it out, kept the sharp parts, cut the doubt. Every draft got a little more true. Every loop brought me back to you. You said, say it one more time. So I made that line my line. If the meaning shifts, let it. I can hold it, I won't forget it. Round and round I get there. Same room, new air. If it changes when I say it, then I need to replay it. I want to reiterate my iterations. Say it again, let it land, let it take shape. I want to reiterate my iterations. Same old heart, brand new way. Again, I'm making it plain. Again, I'm changing the frame. First pass was a little too thin. Second pass let the color in. Third pass hit where it should. Now the rough cuts finally feel good. I don't need perfect the first time through. I need the version that reaches you. So I keep the line, then I bend it right till the words line up with the light. Round and round I get there. Same room, new air. If it changes when I say it, then I need to replay it. I wanna reiterate my iterations. Say it again, let it land, let it take shape. I want to reiterate my iterations. Same old heart, brand new way. Again, I'm making it plain. Again, I'm changing the flame. Maybe I was never wrong, just don't finish all alone. Now the pieces click, they click, and the meaning sticks. I want to reiterate my iterations. Say it again, let it land, let it take shape. I want to reiterate my iterations. Same old heart, brand new way. Again, I'm making it plain. Again, I'm changing the frame.
Reading status filtered.
Three checkpoints done. Currently training on 400. Checkpoint nodes coverage density cost agreement 50 100 14 100% 58. 9 151 ms 52% 100 200 22 100% 63. 1 155 ms 58% 200 450 100% 64. 0 126 ms 66% 400 training. Solid trend. Agreement. 52% right arrow 58% right arrow 66%. Plus 14 pp. From 50 right arrow 200 training units. Climbing. Node count. 114 right arrow 222 right arrow 450. Tilde 2x per checkpoint. Real diversity absorbing. Cost, stable at tilde 140 ms, even dropped slightly at checkpoint 200, 126 ms. This is the credible scaling curve we wanted. If it keeps going at this slope, checkpoint 400 might hit tilde 72%, checkpoint 547 maybe tilde 75%. Training on 200 took 218's 3, 6 min. 400 should take tilde 7-8 min, then 547 another tilde 10 min. Total remaining tilde 20 minutes. Standing by. None. The graph is populated by the substrate's own algorithms only. Train world model onusfulness reads each work unit's text. Embeds it via sentence transformers /all-mini LML6v2, a small encoder model, not an LLM doing reasoning, and sprouts a node at the embedding's coordinates. No LLM is calling, judging, or producing subclaims. So the experiment is testing the substrate's bare retrieval with no judge agents, just observation absorption from raw work unit text. That's the conservative version of the architecture. Agreement at 66% is the substrate doing its work, without any LLM-mediated structure building on top. The judge agent mechanism we discussed, where training agents post structured subclaims using a frontier LLM, would be a separate experiment. This run is a baseline, showing what the substrate alone can do. Want me to run a second pass that adds LLM-generated subclaims as a comparison? That would be the true bootstrap with frontier LLM scenario from our earlier discussion. It's optional given the trend already showing. Honest answer: I'm not aiming for inference complexity at all in this experiment. What's happening? Each session's text gets embedded into 16 decowords by sentence transformers. A leaf node is sprouted at those coords, with the session's first ~80 chars of problem text as its content. That's it. No structured claim, no reasoning about the session, no extraction of what made this work useful. The agreement metric is just measuring whether the locator returns nodes whose embeddings are close to the query's embedding, and whether those nodes happen to come from the same k-means cluster as the query. It's a nearest neighbor retrieval test, not a reasoning test. So when I said agreement climbed to 66%, what that really means is, as more sessions are absorbed, the substrate's locate function returns relevant neighbors more reliably. That's a useful property, but it's not the substrate doing inference. It's the substrate being a slightly fancier nearest neighbor index. The real inference complexity, the one we actually care about, would require an LLM or the substrate at maturity, reading the session and producing structured subclaims about what worked, why, and what the underlying principle was. Those subclaims posted into the graph with PRO/con polarity, parents, depth. Inference walking that depth structure to compose answers, not just returning nearest leaves. Without that step, the experiment is testing retrieval at scale, not reasoning at scale. The 66% agreement says the substrate finds related past work better as it sees more, true and useful. It doesn't say the substrate produces frontier LLM comparable answers. That claim isn't being tested. The honest next experiment, if we want to test the real claim, would add an LLM that reads each session and posts structured subclaims into the graph during training. Then the inference path can walk depth, not just leaves. That's a meaningfully different and more expensive run. Should I extend the experiment to do that? Add an LLM as the judge agent step? Or is the retrieval-only baseline what you wanted to see for now? Right. Use the architecture's own property, fractality, to scope the test. Pick one domain and go deep on it. The substrate within that domain has a much smaller surface area to cover. What we're really testing isn't generality, but whether the depth structure within a bounded domain can produce useful inference. That's the autonet pricing decision case, the alignment scoring case, the substrate itself debugging case. Each is a tight domain where worker activity is plentiful and procedural patterns repeat. If we get statistical significance there, the extrapolation is this architecture works at the depth of domain level. That's the honest claim. It doesn't promise unbounded generality. It promises that within any domain the network operates in, the substrate can become competent. Recommendation for the deep domain test. Pick C, /code /autonet itself. 27 sessions of real engineering work on this exact code base, all about the same things: substrate work, contract design, agent framework, training pipeline. Tight semantic coverage, repeated patterns, clear ground truth. Some sessions actually built on each other directly. Within this domain, 27 sessions is small, but the within-domain coherence is high. Most sessions touch the same 5-6 concepts: charter, agents, world model, training, contracts, RPB. Held out 4-5 sessions as eval queries. Train on the rest with multiple epochs, so the graph has time to develop depth. Add an LLM judge step, where it produces 1-2 structured subclaims per session about what the session actually did and why it worked. Measure, when a held-out sessions problem is queried, does the located region's depth structure correctly identify what the session was about? That's a bounded, tractable test that exercises depth, not just retrieval. The number of statistical comparisons is small, but each is high information because the domain is coherent. The current 597-unit run is too broad. It's spanning 30-plus projects, no domain coherence, embeddings have to do all the work. That's why retrieval only is what we're measuring. Want me to set this up? Cancel the current run, build the autonet-only deep test with judge agent LLM calls. Probably 30-50 LLM calls for subclaim generation, $1-3 of API spend, and the result would be the real test of the architecture's claim. You're right, held out session replay has too many variables. The agent decides what tool to call based on the full session context. What the user said, what files exist, what the agent saw on each step, not just the initial problem. Comparing actions in held out session. To actions, the substrate predicts, runs into a wall of confounders. Even Claude, given the same problem twice, produces different actions. A cleaner test removes the action replay framing entirely. Pick something more bounded. The casting I'd propose, small local LLM 3B7B, the translator. Reads a graph region the substrate surfaces and renders it into a final answer. Phi3 Mini, Q13-7B, Llama 3, 1-8B, any of these. Local free fast. Frontier LLM as Oracle, Sonnet or GPT-4 class. Used only at evaluation time, not in the substrate. Its job, given a question, produce the ground truth answer the substrate's output is judged against. Frontier LLM as judge agent at training time. Same model, different role. Reads each work unit during training and posts 1-2 structured subclaims summarizing what was done and why. Substrate, the engine plus the small LLM as renderer. The contest, narrowed to remove confounders. Don't test action prediction. Test question, answering about the domain. Specifically, given this question about autonet substrate, produce an answer. Sample queries. Why does the substrate use content address node ID? What's the difference between novelty and mint? How does the mint gate use training agent debate? 3 contestants on each query. Frontier LLM alone with no context. Tests how much of this it knows from general training. Frontier LLM with full code in context. Tests upper bound. If the LLM can read the code, what's the best answer? Small LLM plus substrate region. Substrate locates the relevant region. Small LLM renders the answer. Frontier LLM with full code is the oracle for grading the other two. We grade by asking it to score 1-5, how well each answer matches its own. Why this works, the question is fixed. No action stochasticity. The substrate is being judged on whether its accumulated structure plus a small renderer can match what a big LLM produces with full code access. Confounders are minimized. Same question, same grading rubric, 3 contestants compared head-to-head. The small LLM is the same role in both contestants 2 and 3, a translator. So what differs is whether it has the full code or the substrate's region. Sample size for statistical significance, maybe 30-50 questions about autonet. Each question gets 3 answers. Oracle grades each on 1-5. Compute mean scores, do a paired comparison. With 30 paired observations, even moderate effect sizes, (0). 3 standard deviations reach statistical significance with t-tests at p0, 0.5. Generating 30 good questions takes 30 minutes if I write them by hand, or 5 minutes if I have Sonnet generate them from the codebase. API budget. 30 questions times 3 Frontier LLM answers, no context, with code, Oracle grading, equals 90 Frontier calls. With code and context, maybe 50K tokens per call. Estimate $5-15 of API spend. Substrate training, judge agent calls at training time. $30-100 calls, depending on density. Another $2-5. Small local LLM inference, free. Honest caveats I want to flag. This tests narrow domain knowledge synthesis, not general reasoning. If the substrate scores well, the claim is for tight bounded domains, accumulated graph plus small renderer matches Frontier LLM. Not matches it in general. The Frontier LLM as Oracle is biased toward its own answers. Mitigation: ask the Oracle to grade against an external rubric, correctness, completeness, accuracy of code references, rather than is this similar to what I'd say. Small LLM picks, Phi 3 Mini 3, 8B fast is a good first try. If it can't render the substrate's region into coherent answers, that tells us the translator floor is higher than 4B. Practical workflow: generate 30 questions about autonet code by feeding the codebase to Sonnet and asking for them. For each question, run all 3 contestants. Have Sonnet grade all 90 answers blind. Don't tell it which contestant produced each. Aggregate scores, compute confidence intervals. Maybe a half day of work to set up plus an hour of API time to run. Want me to cancel the current run, kill the broad experiment, and set this up?
Reading status filter.
Four checkpoints done, currently on the final 547. Checkpoint nodes coverage density cost agreement 50 100 14 100% 58. 9 151 MS 52% 100 222 100% 63. 1 155 MS 58% 200 400 50 100% 64. 0 126 MS 66% 400 870 100% 64. 0 137 MS 72% 547 training. Real scaling agreement 52% right arrow 58% right arrow 66% right arrow 72%. Climbing monotonically plus 20 pp from 50 right arrow 400 units. Node count 114 right arrow 2. Linear to superlinear in training units, more diverse work units. Cost stable 126-155 ms across all sizes. This is a credible scaling curve. With baseline 12, 5%,
Using task update. Using task update.
Now writing the plan
Writing
to a
reasoning
markdown file
experiment
in the
plan.
experiment directory so it survives.
Using task create. Using task create. Using task create.
Yes, every
Using
completed
task
task in the
create.
cleared list maps to actual commits. Plan locked in, reason in experiment plan. MD in substrate experiment / survives compact. 4 new tasks, #3336, outline the work order. Cleared tasks are all reflected in commits across the 4 repos. Ready for compact.
Reading reasoning experiment plan. Reading status filter. Running LS.
I'll read the plan
Running
and check the
WC.
current experiment
Using
status,
tool search.
then delegate the first phase.
Using task list.
Good work units autonet.
Reading work units
JSON
autonet.
already exists.
Using
Let me check
task
its
update.
size and load tools I'll need. Acknowledged
Running
autonet
LS.
is YP, so questions/grading should target what the code actually says, not idealized architecture. The Oracle rubric needs to lean on accuracy against actual code references, rather than is this how it should work. I'll bake that into the question generation prompt. Questions must be answerable from the code as it exists, and the
Using
Oracle grades
agent.
against what's literally there. Let me check current task state, then proceed. Only
Running
17
LS.
autonet sessions, too thin. Plan calls for both autonet substrate, good
Reading
bounded
init.
domain,
Reading status.
13 substrate
Reading
files,
adapter.
plus
Reading
13
events.
generalized
Reading
engine
infer.
files.
Reading
Now
mint date.
delegate question
Reading
generation.
outcomes.
I'll have the agent read the
Reading
actual
reconcile.
code and
Reading
produce
score
questions
turn.
answerable from what's there.
Reading usefulness cohorts. Reading verify. Reading coordinate frame. Reading tendency. Reading world. Reading equilibrate. Reading locate. Reading decay. Reading grow. Reading observation. Reading render. Running LS. Running LS. Writing questions. Running Python. Reading status filter. Running LS.
Question generation
Running
done,
task list.
30 questions written. Now checking on the retrieval experiment. Status filter.
Running W.
JSON hasn't been touched since 23:47, about 2 hours ago. Last checkpoint was 400, agreement, several
Using
Pythons
PowerShell.
alive. The 2 GB and 3 GB ones are likely the retrieval experiment plus something else. But status hasn't been written in 2 hours, which is suspicious. Checkpoint 400, right arrow 547 is only 147 more units. And prior step, 200 right, PID
Using
200
task
1644, the experiment is still alive. 1. Next up is hash 34, judge agent retraining, which depends on the retrieval run finishing, or at least its substrate state being stable. and on having a Frontier API path wired up to generate subclaims. Want me to proceed with hash 34 setup, or wait for the retrieval run to land first?
Using PowerShell. Using PowerShell.
Killed. Want me to keep going with hash 34, or pause here?
Running in. Reading work units autonet.
On it, hash
Running
34
LS.
is Judge Agent retraining. Substrate trained on autonet plus world model session traces, but each two snags,
task
no
update.
Anthropicopyche end. We have a C code
Reading
world model
usefulness training.
exists. Let me re-extract with both projects and check what OpenAI
Running
endvar
WC.
resolves to. Findings: OpenAI
Searching
endvar
for
is a
dev
real
scrap
escape
child
raj
trained
key,
world model
164 chars. Can drive the Judge Agent via OpenAI. Now I
Reading run
understand the
experiment.
current training. Per work unit, it sprouts one leaf node under the best root tendency. For hash 34,
Using agent.
we want to add one or two LLM-generated structured subclaims to the same parent, deepening the graph. Now I
Reading
have the
run
picture.
experiment.
The
Reading
retraining script
tendency.
needs to extend usefulness training style
Running
flow,
LS.
but inject 1-2
Searching for
LLM-generated
L2
subclaim children per
Searching
work
for class
unit
position
using
class
OpenAI.
PRO con
Let me
RO.
delegate the
Reading
implementation.
usefulness cohort.
I'll stopped.
Reading work units filter.
What would you like me to change about the approach?
Running find.
Got it, using the local Claude Max bridge instead of
Finding
API
files
keys.
matching C.
Let me find it.
Slash code slash autonet slash asterisk asterisk slash asterisk bridge asterisk. Reading bridge.
Found it, C
Reading
Claude
test
bridge, TS and C
Running
bridge.
LS.
Hi. Got the full picture. The bridge
Searching
spawns
for RUN
crystal clear
bridge
now.
line Bridge provider backslash provide. Reading
The
test
pattern
bridge.
is just no API key needed. It goes through the Claude Max subscription via tilde. Credentials, JSON. There's also a 5H rate limit
Searching for
window
session
we
ID
need to
session.
respect.
ID new session fresh S. Running WC.
Now, a
Reading
question
Claude
for you
bridge.
before I delegate the script. How many work units to process for the Judge Agent retraining? Each unit equals tilde1-2 bridge calls. Cost is subscription PCT, not dollars. The plan said 100 units would land in 30-60 min. We have 597 filtered units. We could do all of them or a subset. What's your preference? I'd suggest starting with limit 50 to verify quality, then scaling up if the subclaims look good. Also, model preference for the judge. Sonnet, default, vs Haiku, cheaper on the 5H window, faster but weaker reasoning. For subclaim extraction, Haiku is likely sufficient since it's a structured extraction task, not deep reasoning. Write one bridge subprocess shared across many judge sessions. That means orchestrate-style sessions, not single-shot send. The bridge supports sessionid continuity via prompt caching, and send orchestrate is the multi-turn entry point. But for our case, we don't need orchestrate, no tools to relay. We need many parallel/sequential single-turn sessions sharing one bridge process. Let me reread the bridge's session model. To confirm what confirmed, each create
reading
call to the
outcomes,
bridge creates a
reading
new
init,
SDK session
running
via
LS,
session manager,
running
and
LS,
sessionid can be passed to resume a prior session.
Running LS.
The bridge
running
already
head,
maintains a map of all active sessions in one
using tool
process.
search.
So your model is exactly what bridge provider. Send already does. Each call creates a fresh session under the hood, all sharing one bridge subprocess. We don't need orchestrate. We just need to spawn one bridge provider instance. Call provider, send, n times, once per work unit. Each call right arrow a separate session, sharing the bridge's persistent prompt cache for the system prompt across all sessions. Close at end. The big win, the system prompt gets cached after the first call, so calls 2. N pay ~10% on the system prompt portion. With enable prompt catching 1H already set in the bridge N, we can churn through many work units cheaply against the 5H subscription window. Let me delegate the implementation now with this clarified design.
Riding train with judges. Running CD. Running WC. Running off. Reading train with judges.
Script is in place. 2 issues from the agent's report worth your call before we run. Equilibrate inside the training loop divergence. Running equilibrate every unit drifts world state from what a Plievance produces. It equilibrates once at the end. The agent followed my spec but flagged it. Cleanest fix. Skip equilibrate in the training loop and let a Plievance do it. Otherwise, the saved events won't faithfully reconstruct the trained world. No bridge retry. Transient errors get treated as parse failures, and we lose those subclaims. Probably fine for first run. Recommend fixing #1, drop equilibrate from the loop, then doing a small smoke test with limit 5. Want me to make that fix and run the smoke test?
Reading train with judges. Searching for equilibrium. Reading train with judges. Editing train with judges. Running witch.
Now, before the
Running
smoke
CD.
test, bun requirement, let me confirm bun is on path. Bun 1,
Running
3,
tape.
8 in place. Smoke test with limit 5.
Reading BF9, X8 QC16. Reading BF9, X8
Output
QC16.
is mostly progress bars. Let me read the actual file and look at what mattered.
Running CD.
Subclaims are real procedural insights, not summaries. The judge is doing what we want. But the first one, session 0DDF46C9. C/program files/git/usage is a noisy work unit, an accidental paste with a 2-message session. The judge gave it con subclaims about off-topic response, which is a reasonable read but not informative for the substrate. The next 4 are good. Maybe acceptable noise. The substrate's pruning logic should deweight low-score con regions over time. Status, #34 smoke test phase done. Want me to do the full run now? Options. Limit 100, ~15 min, conservative against 5H window. Limit 200, ~30 min. Limit 597, whole filtered set, ~75 min, max graph depth. Recommend limit 200, gives substantial graph depth. Leaves room on the 5H window for the contestant runs in #35.
Running CD.
Backgrounded as BWBXWH 6CN. I'll get a notification when it finishes. Want me to set up hash 35, 3 contestant runs, in for while this runs. That's the evalware, A1. Claude Via Bridge with no context, answers each question A2. Claude Via Bridge with the bounded codebase in context A3. Substrate locate question, plus small local LLM renders region A1 and A2 share the same bridge mechanism we just used. A3 needs a local small LLM, that's the bigger setup question. Do you have a preference for the small LLM? Options on this machine. Anything you already have via Allama, most likely Path if you have it. Hugging Face transformers with a 3B7B model, heavier setup. Something via the bridge, but with a non-Claude provider. Or, do we postpone A3's small LLM until later and start with A1 plus A2 to validate the contest pipeline? You're right, I shouldn't poll. The background task system auto-notifies when the process completes. I should just wait for that notification rather than checking in. I think the trigger is the system reminders nudging me about task create/task list. That's the harness reminding me about task tools, not a process event. I've been treating those reminders as cues to act, when really they're just background nudges I should ignore unless task work is actually relevant. I'll stop checking in. We'll respond when the background task completes or you ping me. tilde 75 min started at 0038-ish. So expecting completion around 0150. The first unit alone took tilde 9s in the smoke test, model load plus first call cold, and subsequent calls should be faster with prompt caching. Real pace will tell us, could be 60 min if cache hits well. Right, the framing matters more than the specific model. Bridge-only contest, cleanest signal, no local LLM needed. A1, Haiku alone, no context, A2. Sonnet alone with full code base, A3. Haiku plus substrate, locate right arrow render right arrow Haiku as renderer oracle. Opus if A3 approximately A2, that's the punchline. Smaller model plus graph equals bigger model alone, judged by an even bigger model. Inference cost story stands on Haiku vs Sonnet pricing. No extra moving parts. Local plus bridge contest, stronger story but more setup. A1, local QN alone A2, Sonnet with codebase A3. Local QN plus substrate oracle, Opus same shape, but the cost-saving story is sharper because A3's renderer is free at inference time. The bridge-only path is faster to set up. Same bridge provider we already wired. Local QN path adds an Alama integration, but the contest logic is identical. My take: do the bridge-only version first, since the substrate is what we're actually testing, and the contest result is what carries the claim. If it lands well, we run the local QN variant later as a "this is also free" follow-up. That work for you? Good. I'll wait on the judge retraining notification. Won't poll. Once it lands, #35 setup begins. Bridge-only contest with Haiku alone vs Sonnet with code vs Haiku plus substrate, Opus as Oracle.
Using agent.
Drafting now.
Reading questions.
Delegating to a
Reading
sub-agent
bridge.
so I don't
Reading
burn main
locate.
context on the
Reading render.
boilerplate.
Reading aggregate. Reading usefulness cohorts. Running ls. Reading bridge. Reading bridge. Running ls. Running ls. Running ls. Reading world. Reading init. Running ls. Searching for def get node class tree class node pair. Running ls. Reading tree. Running ls. Running ls. Writing run contest. Running CD. Running WC. Running CD. Running CD. Running CD. Running CD.
Run contest. Pi drafted 765 lines, help verified. Codebase dump is tilde 190 KB, which fits Sonnet's 200K context cleanly. Tilde 48K tokens. A3 prompt format looks good. Status, hash 34 still running in background. Hash 35 script ready to run as soon as hash 34 lands. I'll stand by for the retraining completion notification. Loop fired,
Using
picking up
task list.
unimplemented work.
Reading status with judges. Using task update.
Hash 34,
Using agent.
320 slash
Reading questions.
597,
Running LS.
54%,
Running LS.
0 parse failures, 941
Running
world
LS.
nodes. ETA tilde 30
Searching
more
for
min.
DefSyn
Hash
class bridge
35,
provider
script
model.
ready, just
SPR.
waiting on hash
Reading
34
bridge.
output.
Using
That
tool
leaves hash
search.
36, Oracle grading plus analysis. I can draft the grader script now. It reads contest results. JSONL. Blind grades each contestant's answer with Opus on a 1-5 rubric, then computes paired stats.
Writing grade contest. Running CD. Running WC. Running WC. Running file. Reading grade contest. Reading grade contest. Using schedule wake up. Reading status with judges. Running CD.
Hash 34,
Running CD.
398/597, 67%, 0 parse failures, cache,
Using
code-based
schedule
dump.
wake up.
Standing by for hash 34 completion. Hi. Yes, I remember the arc. Graph equilibration as everything computer. Right arrow. Actually, let's see if it can think. Right arrow. Let's measure it. The through line is the same though. The substrate's claim is that structured graph plus small renderer approximately big monolithic model. If that lands, the unified theory part isn't gone. It's just in the architecture itself. The contest is the receipts. But yeah, Archaeology by morning is on the table.
La 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 la. 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 Você tá la 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 la
Reading status with judges. Running tail. Using task update.
Hash 34 done. Checking the result.
Running CD.
Hash 34 complete. Background BFMXNM 2 knee. Ida tilde 15 min. I'll be notified on completion.
Reading status contest. Running CD.
Seven slash
Running
30 done
CD.
after tilde 100s. Pace is tilde 14s per question. Ida tilde 5 dash 6 more min. Let me peek at one row. Early read on Q01. A1, haiku alone. Declines, I don't have context, A2, sonnet plus code. Nails it, exact charter list with line numbers, A3, haiku plus substrate. Declines, but for an interesting reason, locator returned irrelevant nodes. Work units about reading molt/persona files, distance 0. 83-0. 86. The substrate's locator isn't surfacing the judge subclaims about charter. It's surfacing semantically related work unit problems. The corpus is broader than the question domain. These 597 work units come from across all your projects, Molt, Autonet, etc. But only tilde 17 are Autonet specific. This is the corpus mismatch we discussed. The trained graph carries lots of work, but most isn't about the bounded question domain. The judge subclaims live as deeper children of those work units, and the locator's keyword/coordinate match is on the leaf content problem snippet, not the deeper subclaim text. Two implications worth noting before grading. Q0, 1 is unfair to A3 as designed. There's no way the substrate has Q01 relevant nodes when the corpus is mostly off-topic. Other questions may fare similarly. The signal we'll get is closer to substrate finds approximately related work. Haiku tries to extract an answer, which still tests something real, but isn't the headline claim. 2 paths from here. Let it run, see how it scores. If A3 approximately A1 across the board, the experiment validly says this corpus plus this locator plus haiku approximately haiku alone. Honest negative result. Cancel and recorpus. Retrain on a tighter autonet / world model only set. ~17-50 sessions if we relax extraction. Smaller corpus but topical. Which direction? My take, let it finish, see the numbers. If A3 lands at a 1, that's still a credible signal that this retrieval path doesn't compensate, and we know exactly what to fix next round. Better locator targeting the subclaim layer or topical corpus. Killing confirms the kill. Background task notification is just the wrapper noting exit code from being terminated. Standing by. What's the call?
Running CD.
Yeah, let me
Running
look at what's
CD.
there. Pattern is consistent across all 20. A3 keeps declining because the locator is surfacing work unit problem snippets, the leaves, and those are mostly off-topic. The judge subclaims, the deeper layer that would be relevant, aren't being surfaced because the locator scores against the leaf node anchor coords, not the subclaim children. 2 things worth seeing in the data. A3 distances are all clustered in 0. 8-0. 86, uniformly high, meaning the locator is operating in noise floor mode. Nothing in the trained graph is close to these questions. Leaf content problem snippets is what's being shown to haiku. The procedural subclaims, the insight layer, never make it into A3's prompt. So the experiment as designed is testing the wrong thing. We're testing, can haiku synthesize answers from leaf problem snippets? Not, can haiku synthesize answers from judge-extracted procedural insights? The fix isn't a recorpus. It's making the locator and renderer descend into the subclaim layer. Specifically, when locate finds a node, render should include that node's children, the judge subclaims, not just the node itself. The current render returns ancestors plus descendants, but the prompt format uses parent plus node only. Want me to fix the render side to surface judge subclaims, then rerun. That's a small change in run contest, Pi's prompt builder.
using schedule wake up.
Yes, verify each cognitive component in isolation before stitching them together. The pattern from one round trip showed a real defect, and we got there because the system was an opaque pipeline. Let me lay out the components and checks before doing any work, because the structure matters. Cognitive components in the pipeline: judge agent, training time. Reads, problem, resolution, outcome. Emits structured subclaims with PRO/con stance. Already ran 585 calls, 0 parse failures. Output cached in judge cache, JSONal. Verifiable now without recalling the bridge. Locator inference time, A3, given a question text, returns a region top K nodes by distance. Currently chain locator, keyword coordinate. Suspected defective, surfaces noise floor matches. Renderer inference time, A3, given a region, formats a prompt. Currently shows tendency thesis plus parent content plus leaf node content. Suspected defective, never surfaces judge subclaims, the deep layer where the actual procedural knowledge lives. Small renderer LLM, inference time, A3. Haiku synthesizes an answer from the rendered prompt. Probably fine, but untested in isolation. Frontier with code, A2. Sonnet plus 190K codebase dump. Looked good in Q01. Frontier alone, A1. Haiku no context. Looked correct, declined when it didn't know. Oracle grader opus on rubric, untested, draft only. Proposed verification order: I do these in sequence, each producing a small artifact you can eyeball before the next. Check 1, judge agent quality. Sample 5 random entries from judge cache, JSONal. For each, print problem plus resolution, plus the LLM subclaims. Question to answer: are the subclaims real procedural insights about this work, or generic-sounding pablum? Cheap, no LLM calls. Check 2, trained graph structure. Load trained world with judges. JSON, count node depths. How many nodes at depth 0, tendency roots. Depth 1, work unit leaves. Depth 2, judge subclaim children. Confirm the judge subclaims are actually in the graph as children of leaves, not orphans somewhere. Cheap, no LLM calls. Check 3, locator behavior on a known target. Pick an autonet-specific work unit that's in the corpus. We know there are ~17. Use its problem text as a query, does locate. Return the leaf for that work unit at distance, approximately 0. If not, the locator is broken before we even get to render. Cheap, no LLM calls. Check 4, locator behavior on the questions. For each of the 30 questions, what does the locator return? Are distances uniformly 0, 8-0, 86, noise floor, or are some questions genuinely matched by something? Visualize the distance distribution. Cheap, no LLM calls. Check 5, renderer surface area. For one question, show what the current renderer produces vs. What an improved renderer, descend into children equals judge subclaims, would produce. Side-by-side text comparison. Cheap, no LLM calls. Check 6, small LLM rendering with the new context. Run one haiku call with the improved render prompt for one question and compare to the leaf-only prompt. Does the answer change? 1-2 bridge calls, cheap, check 7, oracle on 3 known answers. Handcraft 3 labeled answers, good, mediocre, fabricated for one question. Run the oracle. Does it grade them in the right order? 1 bridge call, cheap, after check 7, we'd know whether each component is sane. Then we'd run the contest at scale. Does this match what you had in mind? If yes, I'd start with check 1. Aligned, doing render fix right
Searching
arrow
for depth.
smoke on 5 right
Asterisk
arrow
render
decide.
region summary graph context. Reading run contest.
Got the surface
Running
area.
grep.
Now I need to know how to walk children from a node. Let me check the tree API.
Editing run contest.
Node, all children and node. Pro-children
Running
slash
CD.
con children give the kids. Now let me apply the render fix. Include up to 3 judge subclaim children per located node with their stance and content. No, honestly, we didn't. We jumped from the retrieval experiment trends are good straight to let's build the contest. A few scaled down validations we skipped, probe the trained graph directly. Before any contest, pick a question whose answer we know is in the corpus. Locate it. Read what comes back. Eyeball, does the graph contain the answer at all? We only learned the corpus was off topic after burning 585 bridge calls and a contest run. A 5-minute Python script would have caught it. Verify the judge agent produces useful subclaims for substrate-relevant work. We sampled
Using
outputs in
PowerShell.
the smoke test and they looked plausible, but we never asked. For a known good substrate development session, do the subclaims capture
Using
the actual procedural knowledge? We trusted Haiku's structured extraction without ground truthing. Compose the components by hand once.
Using tool search.
Pick one question. Manually find the
Using
relevant
cron
work
delete.
unit.
Using task
Read the
update.
judge subclaims for it. Format that as a prompt. Run Haiku on it. Compare to Sonnet Plus code on the same question. One round trip, all manual, no infrastructure. That tells you whether the architecture can possibly work before you build the contest harness. Sanity check the locator against an embedding similarity baseline. Does the locator return the closest work unit by simple cosine similarity for a known query? If not, it's broken before any contest. We built the full pipeline first and discovered the failure mode in the run output. The right order would have been verify each cognitive component on a known good input first, then scale. The good news is we have most of the scaffolding now, so the rebuild starts from a higher floor. The lesson: every cognitive component needs a positive control test before it's wired into a pipeline. 2 experiments. The run contest from earlier was killed already. No experiment processes currently running. The earlier kill stuck and nothing alive. Now stopping the loop and parking the tasks. Loop cancelled, no Python processes running, no bridge subprocesses, #35/#36 parked back to pending. Standing down.
Using task update. Using task update. Using task create. Using task create. Using task create. Using task create.
Right, running
Using
the 4
task
scaled
update.
down validations before any contest rebuild. Let me set them up as tasks, do them in order, and stop after each to look at the result before the next. Starting V1.
Running CD.
First, what queries do we have known answers for? Looking at the autonet session list earlier. Atten daemon singleton, right arrow session 007388057, port locking, Chevin file lock pattern, voice integration modularize, right arrow there was a session about modularizing voice, world model substrate research. Right arrow from the manifesting / from in state sessions, let me write the probe. Hit exit
Running
1,
CD.
script ran, loaded 2,351 nodes including replay equilibrate descendants. But SDDAIR is bursting with 8chef model loading progress, and exit code 1 suggests an error after the print. Let me redirect SDDAIR to null and rerun to see what SDDout actually produced.
Running CD. Using task update.
The exit code is from a Windows pipe v1 net finding. Locator works corpus is the bottleneck. The questions need to be about what the substrate actually has, not about substrate code internals. Want me to proceed to V2, subclaim quality check on a substrate-relevant work unit, using one of these now-known good matches like the ATN Demon Singleton work unit. Or pause and rethink the question generation strategy, first given V1's finding.
Running ls. Running for.
Down no project
for.
dire, matrix only
Running
one
ls.
session. But I see code life, see code white paper, see code world model, see code
Running
matrix.
CD.
Let me get session counts across the candidates. Each only has one session at the top level, but that's because the project dires we used only show top level sessions. Most projects do their work inside the dier, but not at the very top. Let me look more broadly.
Running
Interesting,
for.
most show
Running
only
for.
one top-level session, but each dier is megabytes. That means the bulk of sessions are nested in subdiers, subagent sessions. Empty
Running
first
CD.
messages, first record
Running
is probably
CD.
a system summary, not a user prompt. Let me look at the second. Bash glob
Running
expanded
LS.
tilde to a Unix path that the Python C raw string didn't recognize. Let me use the existing extractor instead.
Running CD.
DAO sessions are mostly about meta-mask debugging, not DAO theory. Substantive sessions thin.
Running CD.
Let me try the other promising candidates. C code matrix, C code life, C code novelty, and also check C. Interesting numbers. Research. 150. Excellent. World model and white paper are both rich and topical. Substrate consolidation, autonet self-integrity, RPB contracts, trustless economy mechanisms, all things the bounded domain questions could plausibly query about. This is the right corpus. Total candidate. World model 13 plus white paper 6 plus life 5 plus matrix 1 plus autonet 17 from earlier equals 42 self-contained on-topic work units. Plus DAO trio 5 for finance/contract context. Question, do you want me to? A. Build a tighter topical corpus. Tilde 42 units from world model plus white paper plus life plus matrix plus autonet. Retrain the substrate with judges and run v2v4 on that. Net tilde 42 units times 1-2 judge calls equals tilde 80 bridge calls fast. B. Added on top of the current 597 unit corpus for total richness. So the Atten daemon singleton hits stay valid and the new substrate internals queries
Using
get
cron
matches.
list.
Bigger graph. Eileen A. The earlier 597 unit run included a lot of off-topic noise, research, getit, persona that diluted retrieval. A tight 42 unit corpus is leaner and all topical. We can validate v2v4 on it. If the architecture works on a small clean corpus, we know it'll scale. Which do you want? Confirmed no jobs. Loop is off. Awaiting your decision on A, tight topical corpus, vs B, topical on top of broad before I move on the rebuild. Yes, that's the claim, full stop. Same reasoning, less effort. Where effort equals inference time compute on the renderer. The substrate is the codified work. Locate plus render is the cheap path through it. The renderer is just a translator. Graph region in, language out. As long as the substrate is rich enough, the renderer can be small. Lower tiers, same claim if the architecture is right. We should be able to keep dropping the renderer's intelligence until we hit a floor where it can no longer translate. That floor is the interesting number. It tells us how cheap inference can get. A staircase like Sonnet renderer, sanity check, should be best. Haiku renderer QN7B local renderer, QN3B local renderer, a 1B model, a small fine-tuned T5/BART/ smaller still. Each tier we hold the graph constant, one expensive build, and swap only the renderer. Plot quality vs renderer size. Find the knee. What's actually load-bearing? Two requirements. The graph must contain the answers. If the graph doesn't have the relevant content, no renderer can synthesize it. This is a corpus and judge quality problem. The renderer must be able to translate located regions into prose. It doesn't need to reason. It needs to read structured graph context and turn it into a sentence. This is a much weaker requirement than answer the question from scratch. The first requirement we've been struggling with. The second we haven't tested in isolation yet. It's the cheaper test. Experiment shape that drops out of this framing, hold the graph constant. Run the same n questions through m different sized renderers. Plot scores. The shape of the curve is the answer. Flat, any renderer works. Architecture validated. Pick the smallest. Steep cliff, there's a real intelligence floor for translation. Renderer must be above it. Continuous decline. Substrate helps but doesn't fully replace reasoning. Mixed result. This is also a much simpler experiment than the 3-contestant contest. One axis, renderer size, one variable, one curve. What I'd build now, topical corpus of tilde40-50 substrate relevant work units. Single graph build using Haiku as judge. We already know it produces useful subclaims. Question set that's answerable from the corpus. not the substrate internals questions that failed. Renderer staircase. Sonnet right arrow haiku right arrow local 7b right arrow local 3b, whatever Alama has. Same sonnet plus codebase baseline as control. We want to know if the bottom of the staircase still beats nothing. Want me to set this up? The staircase experiment is the one that directly tests same reasoning, less effort. Everything we've built extractor, judge trainer, locator, renderer formatter carries forward.
Running witch.
Right, invert
Running
the
cat.
bench. Start backgrounded by
PowerShell.
accident.
Using task
Let me grab
update.
the result. One
Using
model
task
QN3,
update.
5
Using
4B3,
task update.
4
Running
GB.
MK Dyer.
That's the 4B
Using
you
PowerShell.
mentioned. Confirmed. My proposal tier 0 first. Toy domain, control test. Hand build a tiny graph, 20 nodes, syllogism style. Pose 5-10 questions whose answer requires combining 2-3 nodes. Compare QN3. 5,
Writing graph.
4B alone QN3. 5, 4B plus located graph regions. If QN plus graph crushes QN alone, architecture is sound at the floor and we climb. If they tie, the architecture has a deeper problem. Either way, we know before doing anything corpus related. This is one afternoon. No bridge calls, no judge agent, no extraction pipeline. Just a Python script with a handcrafted graph
Writing
and Alama
questions.
HTTP calls. Then tier 1, same renderer 4B on a real corpus, judge built by same 4B. Want me to build tier 0? Building tier 0. Plan, handcraft a small fact graph, syllogisms, transitive relations, Alama
Writing run
HTTP
tier 0.
API up at 127.
Running
28
CD.
nodes about a fictional confederation. Each node is one atom. Now the runner. 2 contestants, QN3. 5, now run it. Tilde 10 questions times 2 calls times tilde 5-10 is per local call equals tilde 2-3 min.
Running CD. PowerShell.
Wait, both A and B answers came back empty. Look at Q1. Q1 alone produced just white space. Q1 plus graph same. That's not all
Using
empty.
PowerShell.
Q1 3. 5 is a thinking model. It emits a block that may be consuming the entire token budget before producing any visible answer. Let me probe directly to see what's happening. Confirmed.
Using
Q1
PowerShell.
3. 5 is a thinking model. It spent all 100 tokens in thinking and produced empty response. The Alama API's /nothing is interpreted as content rather than a control directive in Q1 3. 5. Different fix needed. The cleanest is to read the thinking field and the response field, and use response when present. Fall back to extracting the answer-like content from thinking if response is empty after a much larger budget. Better, just bump numPredict. Let me try with 800 tokens.
Drop that shit.
I गया हूँ बेबी मैं अब तो सबकी मैं फाड़ूंगा हूँ खर सारे नकली झंडे असली आ गड़ूंगा कैरेक्टर चाहे के या जे अलो फेवरेट है मैंने ले लिया रॉकी बिग हिप हॉप बंडल पहले से मैंने ले ली ड्रैगी ना का खली पूरी अपना अब तो उसका लेवल हो गया सा खुल गया वो वाला इमोट लॉकडाउन के शाम में मैं तो रहता था खाली घर वाले बोले बेटा थोड़ा पढ़ ले मवाली मेरे पास में था फोन घर में बहुत ज्यादा शोर मैंने सुनी ना किसी की और निकाला अपना फोन ओपन किया फ्री फायर मेरे पास में था आधा मुझे खेलना ना आया क्योंकि दोस्तों ने मुझे डीजे अलग था बताया उसकी सर्कल लाइट का तो बेटा था मैं बड़ा फैन मेरे दोस्तों को मिलती बेटा उससे पावर जैसे वॉशरूम के बिना कहीं पर लगी होगी सवार हो गया हूँ गेमिंग में अब सबकी मैं फाड़ूंगा उखाड़ सारे नकली झंडे असली आ गाड़ूंगा कैरेक्टर चाहे के या जे अल्लाह फेवरेट है मैंने ले लिया रॉकी बीट हिप हॉप बंडल पहले से मैंने ले ली ड्रैगी ना का कर ली पूरी अब तो उसका लेवल हो गया सा खुल गया वो वाला इमोट लॉकडाउन के शाम में मैं तो रहता था खाली घर वाले बोले बेटा थोड़ा पढ़ ले मवाली मेरे पास में था फोन घर में बहुत ज्यादा शोर मैंने सुनी ना किसी की और निकाला अपना फोन ओपन किया फ्री फायर मेरे पास में था आधा मुझे खेलना ना आया क्योंकि दोस्तों ने मुझे डीजे यालों था बताया उसकी सर्कल लाइट का तो बेटा था मैं बड़ा फैन मेरे दोस्तों को मिलती बेटा उससे पावर जैसे वॉशरूम के बिना कहीं पर लगी होगी सवार ओपन किया फ्री फायर मेरे पास में था आधा मुझे खेलना ना आया क्योंकि दोस्तों ने मुझे डीजे यालों था बताया उसकी सर्कल
Backgrounded again. Estimated 10-12 min at ~30s per call. 1,500 tokens vs prior 400. Want me to wait for the notification or peek at partial output as it streams? Done reading. Wait, Q1B was actually a perfect answer. Thrennies, mule train to Renfall, then Yarrow riverboats to Cavel. Spot on, so the summary stats lied. Mixed B with graph only completed for Q1. A alone completed for 5 of 10. The thinking budget is still insufficient, Q1 3. Trace is productive. Model is reasoning correctly. Margin equals 360, 240 equals 120. Port duty doesn't apply because exports. It just ran out of tokens before composing the final response. This is workable. 2 clean options. Option A, bump num predict to ~3,500 and rerun. Each call costs ~60-80, but we get genuine answers in the response field. Total ~25 min for 10 questions times 2 contestants. Option B, live with thinking trace as answer for now. Extract the conclusion from the trace post hoc. Not principled, but gets us a read on the floor signal today. Eileen A, clean experiment, clean answers, easy to grade. But let me first show you the one clean B answer, Q1, vs the match to trace, because that's the actual finding so far. Q1, which Verdanian city-state supplies cinder iron, and how does it physically reach Cavel's foundries? A alone, thinking trace. Model fabricated, guessed it was about the Wandering Inn, or similar fictional universe, no answer. B with graph. Thrennies is the only Verdanian city-state capable of supplying cinder iron. The physical transport route involves hauling the iron by mule train down to Renfall, where it is subsequently loaded onto Yarrow riverboats bound for Cavel. Cited the right facts. Correct multi-hop conclusion. That's the floor signal. Graph context made the small model go from fabrication or confusion to a clean, correct answer. One data point, but the right shape. Want me to bump the budget and run it clean? Option A. ~25 min.
Editing run tier 0. Running CD.
Running is BCAC 4 at 70. ETA ~25 min. I'll be notified. Sleep well. I'll let the tier 0 rerun finish. Give it a quick pass when it lands and stop there. Results will be in tier 0/tier 0 results. JSON whenever you next come back.